Section 6.4 is about rectangles, and you've probably known about rectangles since you're a little kid. I remember when my kids were little, they had this little puzzle thing, and it had different shapes, and I remember teaching them, even as little kids, that what a circle was, and a triangle, and a rectangle, and that type of thing. So even as a little kid, you probably knew what a rectangle was, but you probably didn't know all the information that we're going to learn today about a rectangle. So let's start off with the definition of a rectangle. There it is right there. Put it up a little higher. There's the definition. As a rectangle is a parallelogram, right? We've been talking about parallelograms the last two sections. Rectangle is a parallelogram with 4 right angles. So let's draw a rectangle, and it looks just like what you think it should look like. All right, you're very familiar with rectangles. And oopsie daisy. Where did it go? Let's try that again. Oh, I know it. I didn't make it a color. Let's try this one more time. All right, there is a rectangle right there. Let's make it a little thicker, and we're good to go. Now, it says it's a parallelogram with 4 right angles. So let's put those right angles in. All right, so make it a little more like a right angle. There we go. There's a right angle. There's one, and another one, and another one. So if this is a parallelogram, remember the definition says it's a parallelogram. So we start off with a parallelogram. Remember, parallelograms that I've been drawing have been kind of slanted. But if you take that slant out of it and you make a right angle, you put each one of those slants at a right angle, then it will look like this, and it'll look just like a rectangle. All right, so let's go through this real quick. Since it's a parallelogram, all the stuff that's true about a parallelogram is also true about a rectangle. So what did we learn about a parallelogram? What was the first thing? The first thing was the definition. The definition was that both pairs of opposite sides are parallel to each other. So that's also true about a rectangle. Remember, everything that's true about a parallelogram is also going to be true about a rectangle. But we have something that's a little bit more special about a rectangle that's not true about every parallelogram. But if this is a rectangle, everything that's true about a parallelogram is true about a rectangle. So what else is true? Well, the opposite sides are equal. You probably already knew that. When you're a little kid, you learned that the opposite sides were equal on a rectangle. All right. What else must be true? The opposite angles. Look at the opposite angles. They're equal to each other, aren't they? That's 90 and that's 90. Same with these two opposite angles. They're congruent. What else is true about the angles? Well, the consecutive interior angles or the consecutive angles must be supplementary, are they? Yeah, that's 90 and that's 90. They both add up to 180. Perfect. What about these two? These are consecutive angles. They also add up to 180. So that thing is true. What's another thing that they told us? They also told us something about the diagonals. All right, so I got a diagonal here and a diagonal right there. What's also true about the diagonals of a parallelogram? Well, we learned that the diagonals are, they bisect each other. So those two are equal, and these two are equal right here. Okay, that's pretty much, I don't think I left anything out. I think that's pretty much everything that we knew about a parallelogram. But let's do this. Let's leave those out for just a second. There's one new thing that we're going to learn about a rectangle, all right? And it has to do with the diagonals. The diagonals of a rectangle. Now, this is not every parallelogram. This is only a rectangle. So the diagonals of a rectangle are congruent to each other. So if I wrote A, B, C, D, what could I say then? Since I know this is a rectangle, what can I say about the diagonals? Yeah, we know they bisect each other because it's a parallelogram, but what's special? What's different about a rectangle that may not be true about other parallelograms? And that's that the diagonals are equal. So what are the diagonals? Well, AC is one diagonal. What's the other diagonal? BD. Now, according to that theorem, what's true about the diagonals of a rectangle? They are equal or congruent. So the diagonals are congruent. Now remember I said that the diagonals also bisect each other? Well, check this out. If AC is exactly the same as BD and they're both being split in half, then this has one tick mark, so does this. But look at this one right here. That's exactly the same because those diagonals are the same. So if I take this number, for instance, let's say AC was 10. All right. And then if it was being bisected, what would this thing right here? What would AE be equal to? Well, that would be 5, and that would be 5. Well, if this is a rectangle, BD must be 10 as well, because the diagonals right here, actually, we learned this. I didn't write it down. I should have written the theorem down. But the diagonals are equal to each other. So BD equals BD. I'm sorry, BD equals AC. And this is being split in half. So if this was 10 and this is 10, they're both all going to be 5. So AE, BE, CE, and DE all have to be the same, which is kind of interesting. That's not always true about every single parallelogram. It's only true when you have a rectangle. All right, so that's the key. That's the big thing about a rectangle that's different than a normal everyday parallelogram. First of all, the one thing that's different is that it has all 90-degree angles. The second thing that's different is when you write the diagonals in there, the diagonals are all equal to each other. And if I bisect the diagonals, all 4 of these are going to be exactly the same. And that's kind of interesting. So let's see what else we can learn about a rectangle. I thought I'd show you these two theorems right next to each other. I said earlier I didn't write them down, so I figured I'd write it down. So here's what the first theorem says. It says if it's a if the parallelogram is a rectangle, so I know that thing right there is a rectangle. Let's use A, B, C, D all the time. We'll just use it again. Might as well. All right, so if a parallelogram is a rectangle, so I know that ABCD is a rectangle, then what's true about the diagonals? They must be congruent to each other. So AC must equal BD. That's what that theorem said. We've talked about that already. Look at this theorem right here. It's kind of the converse. I don't think it's kind of the converse. It is the converse of it. Even though they don't call it the converse of this in the book, it basically is. This says, if the diagonals of a parallelogram are congruent. So what are they starting off here? They're starting off telling you that these diagonals are congruent to each other. And it's saying, okay, it's a parallelogram. They tell you it's a parallelogram, and they tell you the diagonals bisect each other. I'm sorry. Let me start that again. They tell you that it's a parallelogram, and they tell you that the diagonals are congruent to each other. If the diagonals are congruent to each other, what kind of special parallelogram is this then? Well, it's got to be a rectangle. So it's the converse of this. This says, okay, it's a parallelogram. The parallelogram is a rectangle. What must be true about the diagonals of a rectangle? They got to be equal. Then the converse of it says, all right, we know it's a parallelogram. We know the diagonals are equal to each other. Then what kind of parallelogram do we have? We have a rectangle. I hope you see the difference between the two. It all depends on what they tell you up front and what you're trying to take away from it after they tell you that given information. And we've done that quite a bit all year, talked about a theorem, and we talk about its converse, is when you switch the if and the then statement around a little bit. Okay, let's finish this off with this quick little example right here. It's not that difficult. It says a quadrilateral JKLM is a rectangle. So you know this is a rectangle. So there's a bunch of stuff that you know about it. You know that you have right angles in here. You know the diagonals are equal to each other. Then you know everything there is to know about a parallelogram. You know the opposite sides are equal. You know the opposite sides are parallel. You know the opposite angles are equal. You know the diagonals bisect each other. You know a bunch of stuff about it since you know that it's a rectangle. Let's take a look at just the information that they give you, and let's go from there. It says if angle KJL, there's K, there's J, there's L. They're talking about this angle right here. That's equal to 2x plus 4. And angle JLK, excuse me, where's that? JLK, that's this one right here. Okay, that angle right there, that's equal to 7x plus 5. And the question says solve for x. So what are we going to do? Are we going to automatically just set them equal to each other? Do I even know that they're equal to each other? Nah, I don't know they're equal to each other, but I do know this. I do know I have a rectangle. So I'm looking at this angle, I'm looking at this angle, and those are part of a triangle. Look at this. It's a big right triangle right there. Do you see this? See JKL, that triangle? That's a 90-degree angle. That's a right triangle. So these two angles are part of a right triangle. These are also the acute angles of a right triangle. So remember, all the angles add up to 180 degrees, don't they? So 180 minus 90 is 90. That means that this angle and this angle add up to 90. We talked about this earlier. Not today, but in another lecture we talked about it. We said that the acute angles of a right triangle are always complementary. Do you know what that means? That means the other two angles in a right triangle always add up to 90 degrees. So that's what I'm going to do. I'm going to add them up. Don't set them equal to each other because they are not the same. But they do add up. Okay, there's the one angle right there. That's this one. If I'm going to add it to this one, I'm going to add it to 2x plus 4. Those two angles add up to be 90 degrees. They're complementary. And then that's all I got to do is just solve for x. Let's do that. We add like terms together. 7x plus 2x is 9x. 5 and 4 are 9. And you set that equal to 90. Subtract 9 from both sides. So if I subtract 9 from that, I get 81. Divide both sides by 9, and x is 9. And that's all they ask you to do, is to solve for x. They could have asked you to actually find this angle right here if you wanted to. And you could do that. 2 times 9, that's 18, plus 4 is 22. Then how would you find this? You could put 9 in for this if you wanted to, or you could just take this away from 90. What did I say that was? 9 times 2, that's 18, plus 4, that's 22, right? So this is 22. This would be 90 minus 22, which would be what, 68? So you could do that if you want, but they don't ask you that. What do they ask you for? They just ask you to solve for x. Just getting a little ahead of you, just a little bit. Okay, that's basically it. There are a couple other things in here we probably could talk about, but I think that's good enough for right now. All right, good luck with this lesson.